Good morning, everyone. Welcome to the class of C333 Environmental Engineering 2. So, today we will start from the plumbing system. Plumbing system. So, what is plumbing system? Plumbing system refers to the water supply system. That means fresh water supply system, as well as wastewater drainage system. Clear, guys? So, both.
Yes, sir.
So plumbing system refers to the entire systems of piping, fixtures, appliances, etc. for providing water supply and drainage. That means wastewater transfer to a building. Okay. So piping, fixture, appliances, etc. What is the objective? To supply fresh water and to remove the liquid waste. So pumping system comprises of water supply system and drainage system. So the water supply system of a building must accomplish two objectives for proper functioning. Number one, provision of sufficient amount of water to serve each fixture. What is fixture, guys? Fixture is, let's take some example of fixtures. Fixtures are installed receptacles, devices, or appliances to an existing plumbing system which are designed to receive pure water and discharge waste. What are the examples? Lavatory. This is the lavatory. Then sink. This is the sink. Bathtub. This is the bathtub. Water closet. This is a water closet. So these are all the example of what, guys? Fixtures. Each of them have different types of water demand for proper functioning. Each of them has different water demand for proper functioning. This one need higher water to discharge. This one needs a bit lower water to discharge. Okay. So the water supply system of a building must accomplish two objectives. One is provision of sufficient amount of water to serve each fixture. That's what I told you, that each of the fixture has different types of water demand. And if you want them to function properly, then you need to provide sufficient amount of water to each of them according to their demand. Provision of no opportunity of backflow of used water into the water supply pipes. Backflow. What is backflow? For example, you're supposed to, in a building, you have drainage system like this. For example, you have a fixture here, water closet or anything, and then you're supposed to discharge it like this, right? You have a wash basin here, maybe, right? Now the water is supposed to flow in this direction, but sometimes it may happen because of the clogging and other issues. For example, here the water may flow backward. And what would happen? Do you want this? The wastewater will come to your house. We don't want that, right? So backflow is not expected. You have to stop the backflow in water supply system. Did I make it clear?
Yes, sir.
Yes, sir.
The drainage system of a building must accomplish two objectives. Wastewater must be removed quickly, and entrance of vermin, that means insects and sewer gas or foul smelling air from the drainage system into the house must be prevented. As you know that in a water closet, if this is a water closet, then the pipe shape looks like this. Am I right?
Yes, sir.
Now the question is, why this is like this? Why not directly like this? Why not the green one? Why do you need this part? The reason is, look at here. Whenever you are flushing the water, what will happen? The water level, as long as the water level is above this point, as long as the water level is above this point, what will happen, guys? The water will flow from water level is here and water level is here. As long as is here, the water will flow or not flow in this direction. The water will flow, right?
Yes, sir.
Okay, fine. And at a time when the flush is the flush water is empty, I mean the flush water is done with flushing, then the water level will be here. Am I right?
Yes,
There
sir.
would there be any flow? Would there be any flow? Same level. Would there be any flow?
No, sir.
Because we don't have any energy difference. There will be no flow, right? So after
Yes,
the
sir.
flush,
Yes, sir.
what is happening? There is always a water standing here. This is called water seal. That means you are giving a barrier so that the foul gas and vermins, insects cannot come to your house because of this barrier, water seal, right? The foul gas will not come. That the foul gas will be stopped here. It will not be able to come anymore any further. Am I right?
Yes, sir.
Yes,
So
sir.
this is the provision. Entrance of vermin and sewer gas or foul-smelling air from the drainage system into the house must be prevented. That's how you prevent it. In real life, actually, this water seal, this portion is a bit above. I've drawn it a bit down. Anyway, the mechanism is this actually. Okay. Parts of plumbing system. The plumbing systems broadly includes entire system of water supply and distribution pipes, sanitary drainage, and stormwater drainage. Water supply and distribution pipes includes fixture like faucet. Faucet means taps. You know, taps you use to get the water. Valve, tanks, and sanitary drainage include fittings, fixtures, wash basins, sinks, water closets, urinals, traps, waste pipes, sewers, septic tanks, etc. And the stormwater drainage includes the collection and carrying of rainwater to a public stormwater drain or to a pond or river. So these are all part of plumbing system. Now, sometimes this closet, water closet, these are basically two types. One is in this figure, as you can see, you have a tank. Am I right? This is a tank. What
Yes,
happens?
sir.
The water enters, gets stored, and at a time whenever you require, you just flush the water. This is called flush tank. A chamber, that means this, in which water is accumulated and discharged rapidly for flushing out water closets and urinals. Flush tank. So one is flush tank. Flush tank. Water closet. Like this. Number two is flush valve. Water closet. What happens here? A valve is a device located at the bottom of a tank for the purpose of uh, this is just I mean valve. What is valve? uh, Here is a valve. Okay, here is a valve. When you flush it, the valve gets removed and the water quickly dissipates. quickly dissipates So I was talking about flush valve water closet. Flush valve water closet. In these types of water closet, flush one is flush tank. Number one, as you can see, you have a tank. Okay, and whenever you need, you have a valve here. You turn on the key, the valve gets removed, the water quickly rushes to the water closet. Okay, so usually 6 liter of water, it may vary, is stored. Now the second type is the flush valve. Do you see any tank here, guys? Do you see any tank here like this one?
No, sir.
So this is flash valve. What happens here? These flash bubbles are basically a modernized flash cock used for toilets by just pressing the valve. They are widely used in public places like malls, okay? The flash valve is a mechanism used to flush a toilet or urinal, while a flush tank holds fluid in reserve for flushing. A flash valve releases water from the toilet tank and into the bowl or overhead tank. That means uh, these toilets do not require a tank, unlike the flush tank water closet. The water enters the bowl directly from the building's water supply piping. That means you have the water supply piping here inside the wall, right? Now, here, have the piping here. And where does it come? It comes from the, for example, the overhead water tank in the rooftop. You have a tank, right? Water tank. And the water comes from there. And this flush valve, whenever you operate this, turn on this valve, then water rushes directly from this pipe to the bowl. This is flush valve. But remember, since you are directly using this, so you need high pressure. You need higher pressure of water. Here you need relatively lower pressure. Relatively lower pressure. Okay, that's the difference. You need lower pressure here because you are giving pressure here by the water tank, but since you do not have a water tank, dedicated water tank here, you are directly using the pipe water, so you need higher pressure in the pipe. Clear? So I want you to remember these two differences between flush tank water closet and flush valve water closet. Okay,
Ji, sir.
Okay, sir. Ji, sir.
so look at this table. Rate of flow and required pressure during flow for different fixture. Ordinary basin faucet. What's that? This is the basin faucet. Hmm? This is the faucet, that is the tap. How much pressure does this tap need? 8 psi. Then sink faucet, 10 psi. Look at this. Flush valve water closet, how much? 10 to 20 psi. Flush valve for urinal, 15 psi. So this is the urinal, right? It discharges only what, guys? Liquid portion. It discharges what? Liquid as well as solid portion. That's why it needs more pressure. Uh, Okay, as you can see, this is 10 to 20 and up to 20, and this is 15. Okay.
Yes, sir.
Shower need around 12 psi. Okay. Now fixture unit. What is fixture unit? Uh, this pressure requirement or flow rate requirement. Higher is the pressure requirement. Higher is the flow rate requirement. Okay. Now this is not always consistent, by the way, as you can see here. This is gallon per minute. GPM means gallon per minute. Okay, flow rate volume per unit time. So gallon per minute, GPM. It tells you how much flow rate is required in each of the uh, fixtures. Okay, what I was trying to say is this flow pressure and flow rate is not always consistent. For example, here it is 5, here it is 30. Now you can see the opposite scenario here. It is 6, it is 5. Okay. Anyway,
Yes, sir.
so fixture unit. A fixture unit is a quantity in terms of which the load producing effect on the plumbing systems of different kinds of plumbing fixtures are expressed on some arbitrary chosen scale. A fixture is not a flow rate but a design factor. For example, a water closet with flush tank has fixture unit of 5 FU fixture unit, and a kitchen sink has a fixture unit of 4 FU, that means 4 fixture unit. For each fixture unit can be used to estimate demand flow rate and required flow pressure. So this flow pressure, flow rate has been converted to a single parameter which is called fixture unit. According to this fixture unit, you can express their demand. For example, water closet requires how many fixture unit? 10. Urinals, how many fixture unit? Again 10. Then kitchen sink or service sink, how many? 3. Okay, look at this. Flush valve, water closet, how many? 10. Flush tank, water closet, flush tank, how many? 3 fixture unit. So as I told you, flush, in case of flush valve, you need more, 10 to 5. Sorry, I'm doing a mistake here. As you can see, flush valve you need 10 and flush tank you need 5. So flush valve you need more, right? Look at this. Flush valve you need higher pressure. Clear?
Yes, sir.
And again, there are categories like public and private. In case of a public water closet, for example, in a restaurant or in a shopping mall, they are used continuously, one by one, very rapidly, unlike to the private one. So in case of public water closet and fixtures, you need more than the private one. Look at this, 6 versus 10, 3 versus 5. So you need more here in case of public fixtures comparing to the private fixtures. Okay.
Yes, sir.
Water distribution system, direct supply. For example, this is the main pipe where the Dhaka Wasa is supplying the water. And for example, you have 50 psi here, and it is 24-hour service. In that case, you can directly, for example, to uplift the water to up to 3 story, 1 2 3, basically 2 story. This is the ground floor, 1 2 stories. 50 psi is sufficient. Then do you need a motor here? Pump? Do you need a pump here? You don't need a pump because you already have enough pressure given by Dhaka Wasa. So the water will directly be lifted by this pressure. And this is 24-hour service. So this is direct supply. You don't need uh, underground water reservoir or a rooftop water tank. You don't need them. You're just directly supplying them. But that's not the usual scenario. In most of the cases, there is not enough pressure or and the water is not supplied continuously 24 hours, maybe 10 hours or 15 hours. In those cases, what you can do, you can, for example, you do not have enough pressure. Your building is 6 story now. Again, 50 psi or let's say 40 psi, whatever it is, and you see that with this pressure, you can uplift the water up to 4, 1, 2, up to this level. Okay, you cannot uplift the water beyond this level. That means you need more pressure. How to increase the pressure? You use a pump, increase the pressure to 70 or 80 maybe. Then you'll be able to clear, clear guys. Now this pressure, with this elevated pressure, you can lift the water to the rooftop tank. You can construct a rooftop tank or introduce a rooftop tank, and then by gravity flow you can supply the water. The water will directly flow. Number 3, underground and overhead tank supply system. As I told you, for example, you do not have 24-hour service. um, uh, Not all time. For example, 10 hours or 15 hours. In that case, what you do is you have a underground water tank. This is the underground water tank where you store this water. Okay, and then using a pump you lift the water to overhead tank and then supply the water. This is the most common method of supplying water. pumped system. As I told you that you do not have enough pressure here, you need 70, but they have 50. In that case, you can use a booster pump to pump the water directly to every house. You do not need a overhead water tank. You do not need this. Okay, that means here you have 24-hour supply from the Dhaka Wasa. Clear?
Yes, sir.
So this system eliminates the need for overhead tanks and is suitable for hot and cold climate. I mean, your temperature, if your temperature goes below 0 degrees Celsius and you have an overhead water tank, in that case, it may get frozen, the water. Water distribution in a building. Let's see. This is a building, for example. This is your water distribution pipe. You are supplying this water to this floor directly. Okay. So look at these people. How are they getting the water, guys? From bottom to top. What is the direction from bottom to top? Am I right? Are you following me?
Ji, sir.
Water is flowing upward. For these people, water is flowing upward. For these people, water is flowing upward. For these people, water is flowing upward. So this is called upfeed, upfeed flow system. Let's say we have 30 psi here, and with that 30 psi, we can reach up to this level, not more than that, up to this level. So in this case, you can see these people are getting water, and from with direction the water is upward, the water is flowing upward. So this is upfeed zone. Upfeed zone. Now with this 30 psi, you could only reach up to this level. You cannot go beyond this level. What you can do, you can use maybe you can use a pump here to lift the water from there to the overhead water tank. And by this water tank, again, you will supply the water to this source. Now for these people here, how are they getting the water, guys? How are they getting the water? Downward, right?
Ji, sir.
Downward. All right? So this is called downfield zone. This is called downfield zone. we were talking about um, fixture unit, right? We are talking about fixture unit. This fixture unit. So this fixture unit can be used to estimate or determine how much flow rate is required by each of the fixtures. How? Using this figure. For example, look at this table here. A public flash valve operated flash water closet requires how many fixture unit, guys? How many fixture unit for this?
10.
10 fixture units. So if you go to this figure is same to this figure. If you go here, 10 may be here, right? Look, there are two curves, 1 and 2. One is for number 1 is for flush valve. Number 2 is for flush tank. In our case, it was flush valve. So we'll look at 1. 1. So 10. What is the demand? Around 20. This is 30, right? 28 GPM, right?
Yes, sir.
Okay. For a single one. If you have by accumulation of the different fixtures, if you have 500 fixture unit, then you will go up to this level. If it's a flash valve, this. If it's a flash tank, this. This is also an important nomograph which we will be using to design the freshwater pipe size. Okay. Now, to design a water supply system of a building, first of all, we need to look at the zoning. What is zoning? Zoning is actually categorizing which one would be the downfeed zone and which one would be the upfeed zone. That is called zoning. Let's see a design example of water supply system of a tall building. So we have a 25-story building, 10 feet floor to floor, 50 psi at public main. So this is the 20 feet, 20, how many again? How many floors? 25th story, okay, 25th story. This is the 25th story building, 24, this is 25. And Dhaka Wasa, from the Dhaka Wasa service pipe, from the Dhaka Wasa, the pressure here is 50 psi. 50 psi. Public main. Public main means the Dhaka Wasa uh, pipe. Men's and women's toilet on alternate floors. That means, for example, you have men's floor here, you have women's floor here. Men's floor, women's. Men, women. Men, women. Alternatively. Okay? Then three water closets or one water closet and two pedestrian units and two lavatories on each floor. That means in each floor you can go for three water closets or one water closet, two urinals, this or this plus this. That means in each floor you have to provide this and any one from this or this. Maximum pressure at any fixture is not to exceed 50 psi. That means if you have a tap, for example, okay, you have a tap here. Each fixture has a minimum requirement for proper functioning. As I told you, minimum requirement, minimum pressure required. At the same time, it has a maximum requirement. Why maximum? Because pressure means what? You are giving force, right? So if you increase the force to extreme level, then the fixture might break down, right? I mean, of course, it has a limit to withstand pressure or force. If you exceed that limit, then this fixture will break down. So there is a maximum pressure limit, and that is here in this case 50 psi. If you exceed this, then this fixture will break down. Okay, so is not to exceed 50 psi. Okay, flush valve fixtures except on 24th and 25th floor where flush tank are used. I'll tell you the reason. Only in these two floors you will use flush tank, okay, and the other floors you will use flush valve. Why? We'll see later. So that's all about this question. We'll start solving this problem one by one, inshallah. Any question, guys? No question. Okay, then thank you very much. Have a good one and stay safe.